so let's see if we can decode something. So I have a little string of numbers, 72, 44, 17, negative 11. Hopefully you recall. Basically, I'm just checking my arithmetic here, right? And this was encoded with this matrix from before, which hopefully I wrote down correctly. Cool. How do I unencode something?
You have to figure out the inverse of the matrix and then multiply it by your vectors.
Perfect. So I had 72, 44, right? This was a vector I got out of encoding with a matrix, right? So what that means, maybe to recall matrices as a function, is I used this matrix, 4, negative 1, 3, negative 2, right, to go that way. Right? I took some kind of word over here, or part of a word, and I made some kind of cryptogram over here. See that? So to go from cryptograms back to words, I need to follow kind of this arrow. Yes? Okay, so I need to find the inverse function for my matrix that I use to encode this.
Is that when you switch the numbers and then the negative?
Good. So let's remember the 2 by 2 inverse trick, which is awesome. Normally I'd invert this with a calculator, especially if it was bigger, right? Or we could augment by the identity and fiddle this thing around. That would take forever. So let's just remember the 2 by 2 trick. So if we invert this thing, what do I get? How do I do that trick?
Is it you switch the top left and bottom?
Good. So swap the diagonal.
Yeah. So negative 2.
Negative 2 and 4 switch spots. And then what do you do with the anti-diagonal?
Switch the negative.
Yeah. Pop a minus sign on it. So you have 1 and negative 3. And then what's the easy thing to forget here?
Do it over 1.
Multiply by 1 over the determinant. So what was the determinant?
AB
minus. I mean,
So the diagonal product, right? So that's negative 8 minus the anti-diagonal product is
minus
3. Okay, so I got gross matrix, that's, let's see, this is negative 5.
Yeah.
Okay, so I got 2/5, negative 1/5, 3/5, and negative 4/5. Who picked this stupid matrix? Oh, that was me, wasn't it? Right? You guys cool with this? Okay, so if I want to decode this thing, what do I do with that and this? Yeah, just hit this with that. So I'm going to take my inverse matrix, and I'm going to do this the sneaky way. So what did I miss when I copied the inverse over here?
Multiply it all by 5?
Yeah, I pulled a 5 out of, or a 5th out of everything, right? So when I'm done, I'm going to multiply by 5.
Oh, so that's just easier to go.
Yeah. Basically, I want to avoid dividing by 5. I'm going to push it off to the end, and hopefully it'll be even, right? Then I won't have to fiddle around with decimals.
Well, if it's not even,
awkward
we would have a
fractions.
problem.
Good. And if it's not even, I screwed up. You guys see that? This should give me a number, right? So that I can associate it to a word. So let me fiddle this thing around a little bit. What do you get? You get a 5th times
144 minus 44.
oh, cool. 144 minus 44. Good. And something big minus something else big.
216.
3 times 72 minus 4 times 44 gives you
216 minus 176. So 50. I think
Is that
so.
40?
I don't know.
I have no idea. Somebody get a calculator.
You said
Quick,
16
dear God.
It's 40.
40. It's
It's
40.
40.
Okay.
20.
Okay, again, this is a job for computers, right? I'm just doing this by hand so we'd remember the process. So what do I get out of this thing? I get
20.
28, and those are supposed to be letters, right?
Yeah.
So what's the 20th letter?
T.
T. Oh, good. That's good. And 8 is
H.
8. Oh, that's nice. Right? I remember those. So it seems like I can do this. So, thoughts? How do I do the second one?
Same, but using 17 and negative 11.
Yeah, the exact same thing, right? So multiply this matrix by the vector 17, 11, and hopefully you'll get the appropriate letters. Does that make sense? So if you're using this, what do you and your buddy need to agree upon beforehand?
What matrix are you using?
You need to agree on a matrix that you're going to use, and what else?
And what the letters and numbers have in common.
Yeah, how to map the letters to numbers. You guys see that? The inverse, of course, I can get from knowing the matrix. You guys see that? But the number encoding scheme, right? The like, what does 20 correspond to? I just started at the beginning of the alphabet and started counting, right? Do I have to do it that way?
You can assign random numbers to random numbers.
Yeah, you could randomly enumerate, you could use,
ASCII.
sure, yeah, you could use ASCII encoding. That'd let you get a lot more things, right?
When countries do this, is it like all computers, pretty much?
Used to.
Countries don't do this
Yeah,
anymore.
countries don't do this quite anymore.
The Unicode Consortium does this.
There are some more robust methods that kind of industrial espionage or government espionage in place. This is a good method when you don't have tons of computing power, actually. The better methods employ more computing power, not less. So this actually, as much as I'm saying like, hey, yeah, get a computer to do this, this is actually a pretty good method for when you don't have a computer.
Yeah, it takes you like 5-10 minutes to go through and actually decode it when a computer could try every possible permutation of something until it gets something that makes sense and break it.
Yeah, if you pass a string of numbers like this often enough back and forth where a computer can read it, it can of course just do statistical analysis and figure out what's the most common letter and then map that to the most common letter in the language you're using. So oftentimes when people actually do this, they also encode lots of garbage so that it doesn't make any sense. This gets to be a pain in the neck.
Plus,
Cool.
if you were doing this in real life for your encoding matrix, you'd use giant prime numbers. Wow. 2 to the several thousand digits long prime numbers.
Yeah, that's another reasonable thing.
Or you just be honest.
Yeah, or just send everything in.
Plain English. Or
I mean-
hex code.
Actually, one that really worked a lot was plain Navajo.
Yeah.
Right, because when you assume that someone's speaking a language, right,
Yeah,
you can run
see-
statistical analysis and figure out what the most common letter in the messages is and map that to the most common letter in the language. Right? But if you have no idea what language they're speaking, you're sort of totally screwed to start with. So,
There might be patterns, but you don't know what the language is.
yeah.
With